All right, Unit 3, we're going to start talking about functions. The concept of the function ranks near the top of the list in terms of important algebra concepts. Almost all of the higher level mathematical modeling is based on the concept. Like most important ideas in math, it's relatively simple. So the function, how it works is that every input has only one output. So every single x can only have one y. So we have looked at functions, we just haven't called them functions, we've called them linear equations, in the form of equations, graphs, tables, and verbal descriptions. So we're going to look at the rule, multiply the input by 2, and then subtract 1 to get the output. So our input are our x values, and we're looking for the y values. So each one, we're going to multiply by 2 and then subtract 1 to get the output. So we're going to multiply by 2 and then subtract 1. 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 Please notice how I made them kind of an equation, a linear equation, where I would normally write 2x minus 1. So you're multiplying the x by 2 and then subtracting 1. And I replace the x every single time with whatever that input was. So the first one, 2 times 0 is 0. 0 minus 1 is negative 1. 2 times 1 is 2. 2 minus 1 is 1. 2 times 2 is 4. 4 minus 1 is 3. 2 times 3 is 6. 6 minus 1 is 5. You'll notice that every single time it went up by 2. So this is really easy, using the calculation up above to write the equation. So y equals 2x minus 1. And then we can graph this. You can graph by just plotting the points. So when x is 0, y is negative 1. When x is 1, y is 1. When x is 2, y is 3. And when x is 3, y is 5. You will notice that every single time it goes up by 2, and it started at the y-axis at negative 1, so that negative 1 and the 2 are shown right here for the y-intercept and the slope. So in the function rule from number 1, what input would be needed to produce an output of 17? Well, this is harder to find when you than doing it the opposite way, because what you're doing is you're finding the output and then you need to find the input rather than just plugging it into the equation. So we can use the equation we had, which was y equals 2x minus 1, but instead of plugging in for x, we're plugging in for y. So 17 equals 2x minus 1, and now we need to solve for x. So we add 1. 18 equals 2x, divide by 2, and our input is 9. So a function rule takes an input of n and converts it into an output y by increasing 1/2 the input by 10. Determine this output for the rule when the input is 50 and then write an equation for the rule. So the difference between an equation and a function is f of x. F of x means the function of x, so you're finding the answer for the function of x. This is the same thing as y. So you will see those used interchangeably, that f of x means y. So let's look at what it's saying. It's saying that we're taking n and we increase 1/2 of the input by 10. So meaning we have to have half of the input and then increase it by 10. So f of x equals 1/2 n plus 10. Then we need to determine the output when the input is 50. So that's saying f of 50. So we want to know when the input is 50, what is the output going to be? So instead of, I guess this should be f of n, not f of x, since n is the variable we're using. So instead of writing it y equals whatever, we're saying when the input is 50, what is the output going to be? So half of 50 plus 10. Well, half of 50 is 25 plus 10. So 35, our output is going to be 35. So function rules do not always have to be numerical in nature. They simply have to return a single output for the given input. The table below shows or gives a rule that takes as an input a neighborhood child and gives an output of the month he or she was born in. So Max, his birth month is January. Evan, April. Zeke, May. Rosie, February. Nico, May. So it can be a function because no birth months repeat per child, meaning that a kid is only going to have one birthday. So there's only one output for the input. So the output when the input is Rosie. So Rosie, the output is going to be February. Find all inputs that give an output of May. Well, the only input is Nico and Zeke. So what you see is there are actually two of them that have May. But the reason why this works is that each kid only has one output. So you can have multiple outputs that are the same, but they can't go back to the same input. So that's why it does not violate the definition of a function. Functions are useful because they can often be used to model things that are happening in the real world. The next exercise illustrates a function given only in graphical form. So Charlene heads out to school by foot on a fine spring day. Her distance from school in blocks is given as a function of the time in minutes she has been walking. This function is represented by the graphic below. So how far does she start away from school? You will notice that these are going up by 2s. So she is 22 blocks from school when she starts. What is her distance from school after she's been walking for 4 minutes? So 4 minutes is right here, and that is 14 blocks. Then it says, after walking for 6 minutes, Charlene stops to look for her subway pass. How long does she stop for? So at 6 minutes, she's still there, still there, still there. So she stopped for from 6 minutes until 7, 8, 9 minutes. So she stopped for 3 minutes. Then Charlene then walks to the subway station before heading to school on the subway. How many blocks did she walk to the subway? So from the subway station to here, you go from 9 to 11. That's 2 minutes, but how many blocks away did it go? It was really just 2 blocks because she went from here to here. How long did it take, excuse me, how long did it take for her to get to school once she got on the train? So once she got on the train, that's right here, to the 15, that went from 11 to 15, that took 4 minutes.